Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wassalatu wassalamu ala Rasulillah. Amma ba'du. Let's start the code because today we can continue our lesson in this morning, and I hope you are fine today and you are in healthy condition, so we can study effectively. All right. So before we start our lesson, let's pray together. Allahumma inna nas'aluka ilman nafi'an wa rizqan thayyiban wa amalan mutaqabbala. Rabbana zidna ilma warzuqna fahma. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin. Alright. We are still continue discussing about some game theory, and I hope today we can finish the discussion so we can continue to the next topic for next meeting. And I think I prefer to discuss from the last problem, from problem Z and then problem Y, problem X, and so on. And I hope we can finish all of them until problem D. All right. So let's start with problem Z. And Abdullah and Rafiullah already accepted for the last problem. And the last problem is the only interactive problem in this contest. All right, this is an interactive problem. Okay. So there is a game played by two players, and in the game given a graph. Any graph consists of n node and m edges. All right. And the graph is connected, undirected, and connected. And the graph may has a cycle. All right, may has some cycle. That it is guaranteed the graph is connected. All right. And then in this game, every vertex in the graph will be or can be colored with one of the three colors. Let's say color 1, color 2, and color 3. All right. And initially all vertices are uncolored. So one of the player will color all of them one by one. All right. So there are two players. Each player has different role. For the first problem, for the first player, in its turn, he will choose two different colors. Two of three different colors. So she can choose 1, 2, or 1, 3, or 2, 3. He can choose 2 out of 3 colors. Alright. After that, the second player, let's say he is Bob. Bob will color uncolored vertex with one of the color given by Alice. For example, Alice gives him color 1 and 3, so Bob can color an uncolored vertex with 3 or with 1 become color. Alright. And then what is the objective for this game? The objective is for Alice, he will make, okay, sorry, let me explain with the other sentence. So in the final state of the graph, if there is a pair of connected or a pair of adjacent nodes with the same color, then Alice win the game. But if there is no pair of adjacent vertex, there is no pair of adjacent vertex have the same color, then Bob wins. So Bob will avoid coloring two vertex with the same color. Alright. And in this problem, we can choose whether play as the first player or the second player. Alright. And then we have to win the game. Alright. So the interaction format is like this. At first, given the number of test cases. So this is the first test case. And then this is the second test case. In each test case, given n and m. After that, given m edges. Alright. Sorry, the first test case is until this, I think. Is it correct? Yes. Okay. So in the second test case, n is equal to 4 and m is equal to 4. Alright. And then after the graph is given, then we can choose whether we will play as Alice or Bob. So let's see in the first test case, the graph given is like this. And then we play as Alice, and then after that, Bob will color node 3 with color 1. So he color this with color 1. Alright. After that, Alice give another 2 colors, which is 1 and 2. And Bob color the second vertex with color 2. Alright. So in the next turn, because this is color 1 and this is color 2, Alice can give another 2 color, which is 2 and 1. So Bob cannot avoid coloring a different color. So Bob will color it with 1. So there is 2 adjacent vertex with the same color. That's why Alice will win the game. So we win the game. All right. Kemudian after that, let's see in the second sample, the graph given is like this. All right. So for this case, we will play as Bob. So at first, Alice will give 2 colors, which is 2 and 3, and we will use color 2 to color the first node. All right. And then Alice will give 2 color, another 2 color, which is 1 and 2, and let's color second node with color 1. Okay, sorry. In the first turn, of Bob, color node 1 with 2, and then after that color node 2 with 1, then coloring node 4 with 1, and then coloring node 3 with 3. So there is no pair of adjacent nodes with the same color. That's why Bob wins the game. Okay. So now let's see how to solve it. Before that, is there any question? Did you understand the rule of the game? All right. So let's find the optimal strategy for Alice at first. What should Alice do? Or what should Alice does? Yes, okay. What is the strategy for Alice? If you have a solution, so you know the strategy for Alice. All right. Okay, that's it. Yes, that's correct. Yes, that's true. Okay, that's great. You got the solution. So as I already mentioned in the last chat, the strategy for Alice is choose the same 2 colors. Let's always choose color 1 and color 2. In every turn, in every Alice turn, she always choose color 1 and 2. Because less color, it is more hard to avoid the same color for a pair of adjacent nodes, isn't it? So the best strategy for Alice is choosing 1 and 2 in every turn. Alright. If Alice only choose this, so Bob can only choose with color 1 and 2. So how to avoid coloring the same color for adjacent nodes? So in order to avoid that, we will make the graph into a bipartite graph. Is it correct? So if we choose a color, if we color a vertex with color 1, then all of the adjacent node colored with 2. Yes. After that, every node adjacent with 2 colored with 3. And then, sorry, colored with 1 as well. And then the nodes adjacent with 1 colored with 2 again, and so on. So the graph can be partitioned into 2 parts. Yes, that's it. And what is the definition of bipartite graph? One of the definition is bipartite graph is a graph without odd cycle. Why? Because if we can divide the graph into 2, so that there is no edges connecting the same part. So every cycle always has even length. Why? Because cycle is a path from a node and back to the same node. Alright. Without using or yes, without using any edges more than 1. Alright. So if we want to find a cycle in bipartite graph, the cycle always has even length, since we have to go back from the first part to the second part and then go back and forth. So if you want to go back to the same part, the total number of length, the total length will be even. Alright. But if there is an odd cycle, then we cannot make the graph into 2 parts. Why? Because there is a cycle with odd length. So there will be an edge connecting the same part. Alright, so just check whether whether there is an odd cycle or not. Okay, how to check if there is an odd cycle or not? We can just try to color the graph with 2 colors. Alright, so just do DFS. For example, DFS from any nodes. Okay, you got it. Congratulations. And then every time we access or traverse to the adjacent, let's color it with the different color. After that, from this node, we will color with color 1 as well. And then if we want to move to a visited node, if the node is already visited, then just check whether the color is different or not. If different, so it is correct, just continue. But if the color is same, for example, like this, so it means there is an odd cycle. Alright. Okay. Yes, so we already know which player we should choose between Alice or Bob. We will choose Alice if there is an odd cycle. But we will, or otherwise, we will choose Bob if the graph is bipartite. Alright. After that, if we choose Alice, then just output 1 and 2 in every turn until all of the node is colored, and we always win the game. Okay. After that, what shall we do if we choose Bob? How to win the game if we choose Bob? Alright. Do you got the idea? Did you get the idea? Okay. What shall we do if we play as Bob? And we know Alice can choose either 1, 2, 1, 3, or 2, 3. Yes. Protect the adjacent vertices. Okay. Doesn't match any adjacent vertices. Alright. For example, the graph is like this. And then given color 1 and color 2, then what shall we do? Which node we will color first? In the first turn, which node we will color it? Just run PFS. Alright. Yes. For example, we will use PFS starting from this node. And given color 1 and 2, let's color it with 1. And then we continue to this node. Given color 1 and 2, so we color it with 2. Is it correct? And then given color, and then we continue to this node since we do PFS. And then given a color 1 and 3, so we will choose color 3. After that, we continue to this node, but Alice give us color 2 and 3. What shall we choose? Which color we have to choose? Can we win the game? What do you think? In this case, Alice wins the game. Is it correct? So we lose the game. Okay, so let's try another idea, or can we prepare or fix our idea. Anyone has another idea how to what's out pub 2 in order to win the game? What is the strategy for pub? Alright. One of the strategy is we will make the graph bipartite. Alright. And we already did it when we want to check is there any odd cycle or not. When we check is there any odd cycle or not, we already color the graph into two colors. Alright. For example, the graph is like this. Alright. We already know the color of each node. Okay. So when Alice give us color 1 and 3, since we don't want color 3, isn't it? So just color 1 to a node in the first part. Alright. Again, if Alice give us 1 and 3 or 1 and 2, just color 1 here. But if Alice give us 2 and 3, so we will choose 2 and color a node from the from the second part. Alright. Just do that until one of the group is already full, either 2 or 1. After there is a part that already full, and unfortunately Alice give us 2 and 3, what shall we do? Then just color it with 3. Alright. So the color will be like this, all of them 2 in the second part, and then one of them 1 for the first part. Some of them colored with 1 and some of them colored with 3, right? Or the other case, the case where the first part is full before the second part. That's why the color is like this. Or in the other case, Alice is cooperative. That's why we can just color with 1 and 2. Alright. And both of them is correct, isn't it? There is no two vertices with same color, two adjacent vertices with same color. Alright, so this is the strategy for pub. So in the implementation, when we do DFS to find the odd cycle, just store in the vertex. So we create two vertex. V1 consists of the indexes for the first part, and then V2 the indexes for the second part. So we can color it 1 by 1 inside the vertex, inside the vector. All right. Is it understood? Okay, great. Is there any questions for problem Z? And then let's continue to problem Y. Okay. For problem Y, so given n stone. Okay, before that, let me explain the problem first. Given n stone theories or stone factory, or just n pile of stone piles. In the first pile, there are x plus one stones in it. Sorry, just x stones. And then in the second pile or second number, there's x plus one stones. In the third number, there's x plus two stones, and so on. So since the number of stone is sorry, I think it is different between queries and number. There are n stone queries. It means we will solve n test cases. And then in the first test case, there are M1 file, or let's imagine that in the first test case, given an array with length M1, and then in the second test case, given an array with length M2, and so on. And the array, the first value in the array is value x, or just x, or x1. And in the second test case is x2. And then the second value is x1 plus 1, and then the third value x1 plus 2, and so on. Because the number of files is m, or the length of array is m, so so the value in the last array is x plus m minus 1. All right. And then what shall we do for this array? So there is a game. Do you know a well-known game called NIM? Do you know the rule? Yes, all right. Have you played it with your friends? No, all right. Yes. Okay. All right. So for each test case, two players will play a NIM game. And which player win the game? We should know which player win the game. Either the first player, which is Tolik, or Golik. All right. So we will solve a NIM game problem. Is it correct? Okay. So the general rule for NIM game is given an array with length n, and each of them is A1, A2, A3, and so on until AN. And each player can take some stones from one of the pile. For example, the array is like this. So a player can take some stones. For example, the first player take 2 stones from here, so become 2. Or he can also take all of the stone in one pile. Alright, so become 0. The pile become empty. But he cannot do nothing. It means a player can take between 1 stone until A stones. Alright. And in one turn can only take from one pile. Cannot take from 2 pile in one turn. Alright. Okay. So do you know which player will win the game? Will win the NIM game? For example, in this case, which player win the game? Second. Alright, that's correct. How do you know? What is the strategy to check which player wins the game? Yes, okay, second. Yes, correct. The winner is a player make all of them is empty. So the next player cannot make a move. So the next player lose the game. Alright. And the correct answer, the winner is the second player. For example, the first player remove all of this. Alright. Then the second player will take 3 from this. Okay. After that, the first player take 3 from this, for example, and then the second player also take 3. The first player emptying the the last pile, so the second player can empty all of them. Yes, that's just one of the scenario, but second player always has a strategy to win. Okay, how do you think? Okay, yes. So yes, you become the first player, and the second player is me. Okay, you just make a turn first. Okay, sorry, this is 4, not 9. Sorry, I think 9 is like this. Okay, sorry, I think we misinterpret. Okay, yes. So we are agree that the winner is the second player. So how to know which player win the game? Just try to XOR all of the value in the array. if the result is 0, then which player wins the game? Equal to 0? Yes, second. If the XR is equal to 0, then second. Otherwise, if XR greater than 0, then the first player win the game. Alright. Why? Because because if the XR is not 0, then there is always a way to make the XR become 0. If not equal to 0, for example 3, there is always a move to make the XR is 0. Alright. We can also make another move that not 0, but there is at least one way to make the XR is 0. And we will prove it later. But after we prove that there is always a way to make it 0, then the opponents, if in this state the XR is 0, so he cannot make 0 again, but always make it positive. So the opponents can set back into 0. Alright. So the strategy is just always make it 0 until all of them is 0. So we win the game. Alright. Yes. Alright. Then how to prove that there is always at least a move that can make the array 0? So just choose the greater value. Alright. Okay. For example, we know the result of the XR. The result is 3. Not this array, but just for example, there is an array that the XR is 3. Then just change a value with that value XR 3. Alright. There is always a value like this. Why? Because if the XR is 3 or any binary number, for example, the binary number is like this, so there must be a number that this bit is on. Alright. And then if this bit is on, then if we XOR with this, then the result is always less than this. Okay. Even there is another bit before that, the result is less than that. Okay. So there is always a way to make the XOR is 0. And then when the XOR is 0, then we cannot make it 0 again, except change A into A XOR 0. And we know A XOR 0 is equal to A. And we cannot change A into A since we have to take at least one. So that's why there is no way to make from 0 to 0. Alright. Yes, you got it. So just discuss again in this problem. The array is like this. So we need to find the XOR between this. Do you know how to XOR some some integers, some adjacent integers, how to find it. Yes, using which algorithm, using which idea. Yes, that's it. We can use the idea just like prefix sum or prefix XOR. We know if we want to XOR from L until R, we can find the XOR from 1 to R or from 0 to I. Sorry, from 0 to R. It's just same. And then XOR with from 0 to L minus 1. And we know XOR for the same value is equal to 0. That's why if we XOR this with this, then 0 XOR 0 becomes 0, 1 equals, or 1 becomes 0, and so on. So we will know the result. All right. After that, how to find the prefix XOR from 0 to R? Do you know how to find it? Yes. Recalculate. All right. Let's see the constraint. But M is until 10 to the power of 16. So we cannot do it in OM. So is there any other faster solution? One of the trick is to see the pattern. So just write a code. Let me show you. Just write a code to output all of the prefix and then just see the pattern. So let me show you. Let's compute until 20. Let's output I and the prefix. Okay, let's run the code. Yes, okay, up to trick is correct. Okay, I have outputted all of the prefix from 0 to 20. Then can we see the pattern? And the pattern is just like what Abdullah write in the chat. There is a pattern with size 4. You know, if x is the multiply of 4, then just equal to x. Is it correct? And then if x modulo 4 is equal to 1, always equal to 1. And then if x modulo 4 is 2, the result was x plus 1. Yes. After that, if x modulo 4 is equal to 3, then always 0. Alright, so just make a branching for it. Alright. Yes, and you can prove it in for your exercise, I think. Okay, the proof is quite simple. Just prove that 0, 1, 2, 3, the XOR is 0, and then 4, 5, 6, 7, the XOR is 0, and so on. Yeah, because it is just 0, 0, and then 0, 1, 1, 0, and then 1, 1, then the XOR is 0. Yes, after we know that XOR of this is 0, then just continue, because we know this is 0. After that, XOR with this also 0, and so on. Then just continue from 0 XOR by x become x. X XOR by x plus 1, which is the previous is even, and then the next is odd, then always 1. Yes, you can solve it by induction. After that, from 1 to x XOR by 1, and we know x is even, so become x plus 1. All right. So we can solve this problem using this pattern. So after input x and m, just check what is x plus m minus 1 modulo by 4. Okay. Is there any other question for problem y? Okay. So let's continue to problem x. Okay. The input given is only one integer, and the output is also 1. And the game is like this. At first, there is only one pile, consists of n stones. And in one turn, we can divide into some piles, into k piles. But the value of each piles is adjacent. For example, 3, 4, 5, 6, 7, 8. All right. In one move, we can do like this with any k. All right. And then the next player will do the same rule until there is a player cannot move. The player cannot move, lose the game. What is the example when a player cannot move? For example, all of them is 1. So we cannot divide again. Or all of them is 2. We cannot divide again. All right. Then for this problem, we just want to know the first move for the first player. What should the first player do in order to win the game in the first turn? So, for example, in the case where n is equal to 10, the first player can choose k equal to 8 or divide the pile into 8 in order to win the game. All right. For 3, he can divide into 2, which is consists of 1 and 2, and then the opponents lose the game. Okay. And if n equal to 6, the second player always has a strategy to win. That's why the first player cannot win the game. In that case, just output -1. All right. Is it understood? Okay. Before we discuss the solution, I have to go to the toilet first. So just try to find your idea before that. Okay. Please wait some minutes. Okay, let's continue our discussion. All right. Before we discuss this problem, do you know about Grandi number? Mm, yes, that's one of way to find a Grandi numbers. But in some games, for example, a game like this, given an array of integer, and the player or each player can decrease one of the value with with the divisor. For example, if a is equal to 8, then we can just decrease it with 4, or with 8, or with 2, or with 1. But we cannot decrease it with 3, for example. Okay. Then how to know which player wins the game if both of them play optimally? So at first we have to find the Grandi number for each pile. After that, just XOR all the Grandi number. If equal to 0, then the second player wins the game. If not 0, then the first player wins the game. Why? Because in every turn, if the XOR of the Grandi number is not 0, we can always make it 0. And from 0, we cannot make 0 again. So the opponents always make it non-zero. And finally, the lost position is when the Grandi number is 0. All right. And the third step is to find what is the Grandi number. If I not fault, for this game, the Grandi number is the number of prime divisors. If I not fault. For egg, if that is correct, so the Grandi number is 3, since x is 2 to the power of 3. All right. And with the same theory, we can solve this one. Okay. And I haven't proved it. And I still don't know what is the proof. And also for this problem, I don't know why the Grandi number is like that. But but I just follow the other solution. The other solution using or I see from the other solution, he find it using max and it works. So that is the Grandi number. All right. The Grandi number for this case is the max of the XOR. All right. But I cannot prove it. Can you prove it? How to prove that? All right. No problem. Sometimes we can just just guys, yeah, just guessing, not proving. All right. For this case or for this problem, at first we will we will check for some n what is the possible k for this. All right. We know the total or the sum of adjacent integers starting with x, for example, and the length is k. So it is x plus 1, x plus 2, and so on until x plus k minus 1. What is the sum of all of them? The formula for sum is just k divided by 2 times 2x plus k minus 1. Yes, yes, it's correct. Then just find any k that the that there is x, so that this formula is equal to n. All right. So let's break this equation. So it is 2n and then 2kx plus k squared minus k. All right. And then we can move it to the right side. Become like this. And then let's move to the right side. That's why x equal to 2n plus k squared plus k divided by 2k. All right. Then just check any k one by one from k equal to 2 until some value. Is there any k so that this formula is divided by 2k? If it is divided by 2k, then that value can be applied for n. Okay. And we know, since we know x is greater than, okay, I think this is minus. Yes. A plus equal to n. Yes, that's correct. The formula is same, I think. Okay. And we know x is greater than 1. Is it correct? The number of piles should be greater than 0. That's why since we know this is greater than 0 actually. So 2n minus k squared plus k is greater than 0. So k is just around until n square root. All right. So we just need to do for loop until square root, or more precisely, we can do for loop like this. All right. So let me show you the implementation. If we want to find for some n, we can for k from 2 as long as 2n squared minus k squared plus k greater than 0. All right. And you know, this for loop, the complexity of this for loop only square root n. Do you believe it? If you believe it, so no need to prove it. Just believe it. All right. The complexity is just square root n. All right. No, this is not n squared. I think just 2n. Okay, that's great. This is just 2n, not squared, not n squared. All right. Then yes, that's great. After that, just check this value. If it's divided by 2k, let's see if this is divided by 2k. If not divided, just continue. But if it's divided, then just just divide it by 2k, and that is the value of x. All right. So we shall use dynamic programming for this problem. Let's dpn is equal to the XOR of Grundy value, or just Grundy value if there is a pile with n stones. It is the Grundy number. So if we can make a move from this value to this, so the next Grundy number is the XOR of all TP of this TPX, XOR with TPX plus 1, and so on. So we can use dynamic programming for n equal to 1 until the real n. All right. And then if there is a k like this, just check the XOR of all TP here from x until less than x plus k. Is it correct? It is correct, but not optimized. Not optimize it. Don't worry, we will optimize it later. We will XOR all of TPI. So what does it means? We will find the XOR of the Grundy number of each piles. If the Grundy number is 0, what does it means? It means there is a way, to win the game. To make the XOR of the Grundy numbers is 0. So just make that move. So the opponents will make the Grundy number positive, and we will revert back to 0, and so on until we win the game. All right. So if we can make it become 0, so it means we can win the game. And for this problem, we will we want to know it for n equal to the real n. If it is the real n, and finally we found a K that causing can make us win the game. So just output it. And we want to find the minimum one. So that's why it is correct since we iterated from the list value. So just output the value of K. All right. But if it is not 0, then don't move to that since we can lose the game. All right. So the best strategy is to make the currently number is 0. Okay. The XOR of all currently number is 0. All right. After that, what if n is less than the real n? Then do nothing since we don't need to output that. And then how to find the dynamic programming for n? The dynamic programming for n is the max of r, not maximum but mix. Mix value. All right. So how to find the mix? So we can just use array of Boolean. Yes, just make an array of Boolean. For example, visited. All right. Not necessarily visited. And we have to memset the visited array. This is not optimized yet, but we will optimize it later. Let's make it visited. After that, just find the first value that is not visited. Yes, that's correct. We will optimize it using that way, but I will explain you first, and then let's optimize it. Okay. So you can focus to understand the solution. After that, you can focus to optimize the computation. All right. After that, we can. Yes, that's correct. After that, we will find the mix using this. Start from 0 until yes, just repeat forever until it is not visited. So there is no r equal to that. If there is no r equal to that, then TPN equal to that max. This is max. Actually, this is max. Want to find the max. All right. Yes, and finally, we will already know the answer, and don't forget to output -1 if there is no way to win the game. So there is no r equal to 0. That's why fish 0 is still false. So the max is 0 and TPN is 0. Because TPN is 0, So the XOR of our current D number is equal to 0. So the second player has a strategy to win the game. All right. Yes, this is the solution. All right. Before we optimize the calculation, is there any question? We need to store n and then Boolean this. Really, Boolean this no more than square root. So it's okay if we hit xn. Okay. Is there any question? So let's optimize it. At first, how to optimize this is a triple for loop, and we can optimize it using Apollo's idea, because we can use prefix XOR for the TP. So let's make a pref. After we find the value of TP, then okay, we call repeat, since we repeat forever. Pref n equal to pref n minus 1 XOR by TPN. That's why here we can optimize it. We can optimize it with r equal to pref k plus x minus 1 XOR with pref x minus 1. Is it correct? Is there any question for the optimization? So the complexity is decreased. And how about this? We will do memset n times. Then the complexity become n squared. Is it correct? Do you know how to? Okay, you can use a set complexity log n. But actually, there is another way to make it set O1. Do you know how to reset an array of Boolean in just O1? Anyone know how to do that? No. Okay. In order to reset a visited like this or array of Boolean in just O1, we can make it integer and then make another value j. Then we can reset using j plus plus, and then we can set with equal to j, and we can check is it visited or not. Just check is it equal to j or not. All right, you got it. Did you understand this trick? All right, congratulations. Okay. Okay. All right. So what is the complexity of this memset? Oh, all right. Yes. It is can be done if we want to do BFS, for example, or TFS. Sometimes many times, and the total number visited is just on, but we need to reset many times. So don't use memset since the complexity is on. We can use this J++. So the complexity is just on. All right. This is if the data type is Boolean. What if we want to reset GP? Do you know how to reset array of integer in just on? Anyone know the trick? For example, there is an array A. We want to reset this in just on complexity. Any idea? The idea is similar. Just just create another integer version and j. And then if we want to access the value, if we want to get the index I, don't just return AI, but we have to check is the version is equal to j. If the version is equal to j, then return AI. But if this is the previous version, so just make it equal to j and reset the value, become 0, for example. All right. Or we can just make it like this. If the version is before this j, then reset first before you use it. And in order to memset, just j++. Is it correct? Yes. And also for the other data type, for example, string, we can also use this. Okay. All right, that's one of beautiful in order to memset an array in just O1. Okay. And then yes, and then the solution is final. Just check for some inputs. And let's see, is there any bug? All right, the answer is 8. This is correct. What if the input is 6? Minus 1. If the input is 3, then 2. All right, it's correct. Now, is there any question for this problem? So let's continue to the previous problem, which is problem W. Another name game. Yes. This is just a name game, but we have to choose exactly and divide by two non-empty files. So if the number of non-empty files is less than n divided by 2, then that player lost the game. Alright. Is it understood? Alright. Then do you know the solution how to win the game? What is the strategy to win the game? Okay. Yes, that's correct. Do you know why that is correct? The strategy, yes, yes, that's correct. So the first player can win the game if the number of minimum, for example, we want to know the minimum of A, the minimum of array A. Then we want to find the number of minimum in array A. Let the count is F or frequency. Then if n is less than or equal to n divided by 2, then the first player win the game. Otherwise, the second player wins the game. Alright. So a player lost the game when he got more than n minus 2 minimal value. Alright. How to do that? In order to do that, just avoid to reduce to the minimum value. So if some of them is minimum and the other is not minimum, so just choose some of not minimum value become minimum. So the number of minimum or f become added by and divided by 2. Is it correct? Added by and divided by 2 means always greater than and divided by 2, since f is always greater than or equal to 1. Yes. All right. And then the next player, if if the number of minimum is greater than n minus 2, that's why sorry. If in that case, when we choose n minus 1 piles, one of them is equal to the minimum. So that player always reaches the minimum. All right. And when he reaches the minimum, the number of new minimum will never exceed n divided by 2. Why? Because if he want to reach it like this, then the number of minimum is just n divided by 2. So the opponents can avoid reaching the minimum. So in this case, just avoid reaches the minimum. And then the next player always reaches the minimum. Yes. And finally, the solution for this problem is complexity On. But when the problem author make it 50, maybe to distract the participants. If the given n is big and given a is big, then the participant will find the ON solution. All right. But if n is small, so the participants will find some brute force solution. Yes, maybe just want to distract the participant in order to not finding the ON solution, but finding some brute force solution instead of do some observation. All right. Yes. And then, okay. Is there any question for this problem? Then just continue to the next problem. All right. So given n logs, log with length m meters, and there are n logs. And then in one move, will wait, a player can divide a log into two or more equal parts. For example, 3 equal parts. And then the length of each part should be integer. So if the length of log is, for example, 21, then we cannot divide it by 4 or 5. We can just divide it by 3, 7, or 21. All right. And a player that cannot make a move lose the game. Okay. Then we can just find the Grandi number Is it correct? The Grundy number of M, and then just do XOR for all of them. So yes, so if N is even, then even number of Grundy number will XOR together. Do you know what is the result for this some Grundy number? Just 0. Okay. Yes. And Abdullah already is the idea. What is your solution? Okay. So if N is even, so the XOR is 0. That's why the second player win the game. Which one is the second player? Marcel. Yes. Okay. Yes, if N is even, then the result is always Marcel. All right. And what if N is odd? Then the result is equal to just Grundy number. Is it correct? So just check, is the Grundy number is 0 or not? If 0, then again Marcel win the game. If positive, then Timur wins the game. Is the K is fixed? Okay. Oh, sorry. In the third, no less than K. Okay. Yes. All right. Yes, that's correct. Yes, the greatest solution is to find the Grundy. Okay. So you know Grundy number is the number of move to make it uncuttable. What is the number of move? So if the initial lock is uncuttable, then the Grundy number is 0. That's why Marcel wins the game. But if it is cuttable, so the Grundy number greater than 0. We don't know what is the value, but always greater than 0. That's why, because it is not equal to 0, then Timur can win the game. All right. Yes, that's correct. And that is the proof. And what is the strategy? Just always make the XOR is 0. So in the case when N is even, just follow the move done by the first player. If the first player cut into 3, then just cut into 3 for the other lock. And if the first player cut this into 2, then just follow. And then if the player cut into 2, then just follow it. So the second player have always has a move. That's why the second player wins the game. All right. And how about this? In this case, we cannot divide any lock. That's why in the first turn, the first player loses the game. That's why the second player wins the game. All right. Okay. After that, what should we do if in this case, in the case where the lock is odd? So just choose one lock and then the other lock is paired. If the first player cut cut a paired lock, then just follow the moves. All right. But if the first player cut unpaired lock, just cut this lock, become the grid number equal to 0. All right. Yes, I think it always can be done. So the second player will win the game. Okay. Is there any question for this problem? So problem V, problem X, and problem Y is about Grandi theorem. Grandi theory, and again for W, also using the similar idea, which we always make the state become become f greater than n divided by 2. Okay. Is there any other question? I think there are only 2 problems left and you can solve it by yourself or just ask to your friends. Okay, and then I think in the next session we can discuss the other topics. How do you think? Which topic you want to discuss it next? About what? But about graph maybe or square root composition or another tricks? Number theory, okay. After game theory, we will discuss about number theory. All right. Okay. Thank you very much for the discussion for today and happy Friday. So see you again in Monday, inshallah. So let's close our meeting with praying kafaratul majlis. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamualaikum ala nabiyyina Muhammadin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.